and functions. Let's start developing how to work with radicals, how to simplify, and how to work with equations. It's a lot of information, a lot of a foundation. It's helping build a foundation to how to work with radicals. By itself, we say the number is squared. Often we need to know what the number was squared in order to produce some value a. If such, call this number the square root of a. Of a if c squared. Let's mention some facts about roots. A number has two real numbered square roots, has just one square root, 0 and itself. The negative numbers do not have real number square roots. So for example, 16 has negative 4 and 4 as square roots because negative 4 squared is 16. It was positive, right? And also 4 squared is 16. A real number square root because there's no real number c for which a number is negative 9. Negative. Be able to multiply it by itself twice. Negative number is its root. The symbol square root of a represents the principal square root of a. To a, we can write a negative on the outside, so negative square root of a. Each of the following. I'm sorry, the square root of 81. So I want to think, is there a number such that when I square it, I get 81? 9. So our answer is 9. We can apply the square root separately. So for 16, such that when I square it, is there a number such that when I score it, I get 81? And yeah, we did this one already. Our answer is 8. Our answer would be 4. This it'll become a lot more second nature. Approximate each of the following. Now, some numbers are not perfect squares. So, for example, 13, can we think of such that when you multiply it by itself, our answer is 13? But luckily, for such numbers, we can use our calculator. So, take a moment to do some, see where your square. And you don't want to write those many numbers, so why don't you round to maybe two decimal places? So 3.6, and then if I want to round to two decimal places, look at the next number. So in this case, 3.6. Let's just practice punching it into our calculator, and for the answer is 2.95. Let's round to two decimal places, 22 point. Have a negative, we just leave on the negative on the outside. And square root of 8423.796. So if we round, it would be 91.7 using your calculator. Radical, radicand, and radicand expression. Radical expression. The radical, the expression written with a radical is called the radical expression. The expression written under the radical is called the radicand. So like if I have square root of 2, the 2 is called the radicand. Like 3, evaluate. What's the square root of 100? Get 10. The square root of 9, 13. What number squared gives me 100? Of a squared. To 0. Of the number squared is equal to a. Exponent of 2 and the square root of 2 and the square root of mathematical opposites, so that you're left with what's on the inside. In this case, of a squared, a squared number. If I take the squared, we always option. So that's why we include the absolute root of a is the absolute value of a. Let's go ahead and look at these examples. Example, assuming that the variable can represent any real number. So what we notice here is I have a square root and a square. You're probably like, okay, my professor said they technically undo each other. So we're left with what's on the inside. The positive only. The absolute value of y plus 3. About this a lot more in detail sooner. I want to think of how many ways can I um, break down that exponent of 2. 2 times m2 times expanded are m12, but I know that if I multiplying, I can go ahead and add my exponents. And if I split this up into radicals, I have square root of m squared squared. And don't worry, I'll walk you so that you don't ever have to write this many square roots again. We get just m. The second one, we get just m. Get just m. For the fourth one, m times 1, 2, 3, 4, 5, 6. M to the 6th power. That is our answer. The square root has an index. That position is called an index of 2. And it's technically dividing by 2. So we would like to consider 12 divided by 2, you get 6. Thus our answer is n to the 6th power. Blue values because I want the positive option. Won't make you do the same thing. Now remember, the square root has an index of 2. You get x so that you have a lot more m's. -27. Negative. Is that negatives? Times itself 3 times gives me 27. I can work with negatives and cubics. I put absolute values whenever I have a variable. I can an odd natural number. Then for any real number, the same. They're technically to get negative power even times and get a negative. positive, a negative, a decimal, or college algebra, or pre-calculus. To the fourth power. Therefore, we just get an m. But because, hey, what's negative? We can't have a negative as a radicand. Expressions. For A, when k is an even natural number. We want the positive. Negative A is even unless it's non-negative number, meaning like a cube root, fifth root, absolute value if k is odd. Because we can take functions. Example 7. For the given functions, find the formula. Let's plug in as a grouping symbol. We have to do what's on the inside first. 4 and 4 minus 1 is 3. Of 4 times 6 is 24. 0 for x. Of 4 times 0 minus 1. 4 times 0 is negative. And we'll leave it like that for now. Radical equation. Radicand 0, but equal to 0 is okay. So we want to solve for it when it's greater or equal to 0. By itself, values. Let's make a chart to graph this. 3 and pick bigger numbers from that. So like of negative 3 plus 3. 2 plus 3. 0 plus 3. We get 7. Equation. We're going to look this way. We can reflect it over the x-axis, shift it. Always look functions and functions. Thank you.